All right, answers to differential equation applications. This is Monday's assignment. So first thing it wants is if P of 0 is 500, find P of T in terms of T and K. So that means T and K are going to stay in my answer whenever it says something like that. So I divide by 800 minus P, multiply by dt. Notice that my variable is negative, so when I integrate, I'm going to get a negative natural log of the absolute value of 800 minus p. On the right side, I integrate, I get kt. Don't forget about your plus c. Plug in 0 and 500. So 800 minus 500 gives me the natural log of 300. 0 over here just leaves me with c. So I plug that in. Negative natural log absolute value of 800 minus p equals kt minus the natural log of 300. Okay, again, they want T and K in your answer. I've got T and K, so all I have to do is solve for P. So I start by distributing the negative and then get rid of the natural log, so I'm going to E both sides. So absolute value of 800 minus P on the left. On the right side, when I put the E on it, the E and the natural log of 300, so that 300 is going to move out front and leave me with negative KT in the exponent. Get rid of the absolute value by adding the plus and the minus. And then I'm going to subtract 800 and then multiply by a negative, gives me that. Then I have to decide whether or not I want the positive or the negative. When I plug in 0, I have to get 500. If I'm sitting at 800, that means I have to subtract something else to end up with 500. So there is part A. Part B, find K if P of 2 is 700. So I put 700 in for P. I put 2 in for T. Subtract the 800 gives me negative 100. Divide by negative 300 gives me 1/3. Natural log of both sides. Divide by negative 2, and we found K. So then I plug my K back into my problem. I get this. Then it's asking for my limit. 800 minus 300 minus or times e to the 1/2 natural log of 1/3 t. I can change this 1/3 right here to a 3 to the negative 1. And remember, a property of logs is if I have an exponent inside, I can move it to the front. So this 1/3 turns into 3 to the negative 1. So then I move the negative out front. And remember the other day when we did this limit process, if I have e to a negative power, this whole thing is going to turn to 0 because I'm going to have 300 over e to infinity. And a number over infinity is always going to be 0. So 800 minus 0 gives me 800. Number 2, so population increases at a rate proportional to the square root of the population. So dp over dt equals k times the square root of p. I'm going to divide by the square root of p. Again, it moves to a negative exponent since it's an exponent of other than 1. Integrate that, gives me 2p to the 1/2. Integrate the right side, kt plus c. Plug in the initial condition, which was 0, 2500. So I plug in 2500 there. I plug in 0 there. We end up with c being 100. So I plug in 100. Then I'm going to plug in 3605. So I plug in 3600 here. I plug in 5 there. So 120, subtract the 100 over, gives me 20. Divided by 5, that tells me k is 4. Now all I've got to do is plug that in and solve. So I divide by 2, and then I square both sides. I get p equals 2t plus 50 squared. So that's all number 2 wants. Number 3. So the rate is proportional to the number of verbs remaining to be memorized. So that is dy over dt equals k times 50 minus y. Divide by 50 minus y. Again, my variable is negative, so that means when I integrate, I'm going to get a negative natural log of absolute value of 50 minus y, kt plus c on the right side. Plug in, it says initially the student has memorized no verbs, so that means we're going to plug in 0 and 0. So if I plug in 0 there and I plug in 0 there, that means c has to be the negative natural log of 50, which I put in there. And now we want to plug in our second one, which is 30 minutes. And again, we talked about this in class. Notice we have minutes here, but the problem is going to eventually ask for hours. So instead of 30 minutes, we want to put in 0.5 hours. So we put in 0.5 for t. and we put in 20 for y. So 50 minus 20 gives me 30. I add the natural log of 50 over, natural log of 50 minus the natural log of 30. That turns into the natural log of 5/3. And then this is 0.5 is the same thing as 1/2. So I multiply it by 2. We get k is 2 times the natural log of 5/3. Stick your k back in there, and now we want to solve for y. So switch the signs, which I did there. Then we want to e both sides. Again, natural log of 50 turns into a 50 coefficient of 50. Get rid of the absolute value, subtract the 50, and change the sign. So we get 50 plus or minus 50 e to the negative 2 natural log of 5/3 t. Figure out whether or not we want the plus or the minus. Remember, when time is 0, we have 0 verbs. So in order to turn 50 into 0, I've got to subtract something. So that's why we chose the negative. Then we want to know how many verbs will a student memorize in 2 hours. So I plug in 2, and then we solve. So once you do that, you get 43.52, but you can't learn a partial verb. So we're going to say the answer is 43. Okay. After how many hours will the student only have 1 left to memorize? Remember that y represents the number of verbs memorized. Okay, so if there's only 1 left, then that means we memorized 49. So we plug in 49 and we solve for t. So I subtract 50, gives me -1. I divide by -50, gives me 150. Take the natural log, divide by 2, and then divide by the natural log of 5/3. When I punch that in, I get 3.829 hours. And number 4, this is Newton's law of cooling. So we have a pie that's pulled out. It's 450 degrees when it's pulled out. The room is 70 degrees. So when I set up my differential equation, we're going to have T minus 70 because 70 is the constant temperature. The constant temperature always goes there. Divide by T minus 70. T is positive, so we're going to get a positive natural log absolute value of T minus 70. Over here on the right, I integrate K, I get KT plus C. And it says after 30 minutes, the pie's temperature is 200, so we're going to plug 200 in for, whoops, I forgot to do 450. So we got to plug 450 in first at time T equals 0. So that's the natural log of 380 is C, so I plug that in. Now we want to plug 200 in, and we plug in 30. Now notice this time the problem is asking for minutes and they gave me minutes, so that means I don't have to change anything. I can go ahead and plug 30 in. So I plug in 30, I plug in 200, 200 minus 70 gives me 130. I subtract the 380 over, combine those logs, we end up with a natural log of 13 over 38, and then I divide by 30, there's my K. So I plug my K back in, and now we want to solve for T. So I E both sides, so the natural log of 380 turns into a coefficient of 380. I get rid of the absolute value, which makes it plus and minus. I add the 70. So there is my function. And then I have to choose the plus and minus. So I'm at 70. When I plug in 0, I have to get to 450. So if I'm at 70 and I want to get to 450, then that means I have to add. And then it says, how many minutes after being removed from the oven will the temperature of the pie be 100? So I stick in 100 for my temperature, and I solve for time T. So I subtract 70, which gives me 30. I divide by 380, and then I E both sides. So I end up with a natural log of 3/8 on the left, 1 over 30 times the natural log of 13/38 times T on the right. Multiply by 30, divide by the natural log, punch it in your calculator, you end up with 71.011 minutes. So after the pie is pulled out at 450 degrees, it will be 100 degrees, 71.011 minutes after it's pulled out. So there are your answers to differential equations application.